Hi there, I'm Andrew Bunnell, and today let's take a look at the Ampere law experiment. I even got an extra wire on my head so I can have a better top-down view of this equipment. So let's go ahead and fade to that top-down view. So let's see, let's shift it just a little bit so you can see just a little bit more. How about right about there? All right, it's hard to see, but I got a power supply right here, a precision resistor. I got a multimeter just off the screen. I got this little gray box. This will be adjusting the Hall probe voltage. Then we got another multimeter, and here's the Hall probe itself, and now we got a big coil of wires and a path around it. You'll notice that the coil of wires is kind of a little bit warm, and if you drag this, or if you move this magnet probe around it, you'll see that the magnetic field is three-dimensional. And to make things easy, we're just going to measure along a flat surface that's parallel to cancel out the z component. So now I've pre-made my measurements, but let's talk a little bit about them. So here's a closer up view of a path, and the path needs to be in 2 centimeter chunks all the way along there. And so if you make a mistake and it's like a 1 centimeter, you gotta go and change that and fix your path so it's 2 centimeters all the way around. And on this one, I started 1 and went all the way around, and notice I have arrows showing which direction I'm going. And as I'm moving the mouse, I have to keep the mouse going in the same direction. So here, and then I rotate, and then I rotate, and I come back. If I change the direction of the arrows, then I'm going to get some bad measurements, and I'd have to multiply those by a negative. So make sure you keep track of which directions you're going. And right here I said I had part 1 is 1 through 44, then part 2 is 7 through 28, and then 45 through 54. Now on this one that I just took today, I did it a little bit different. I started right here in the middle, and then I went all the way around the outside, and I had 38 measurements going around the outside, and then I had another couple measurements going to 45 coming through the middle. And so for my outer loop, I just do 1 through 38, and then for my inner loop, I just start at 20 and go through 45. All right, so to save some time, I've already taken all these measurements, and so let's go ahead and fade over to my Origin screen and type in some numbers. So here are the voltage measurements that I took with the probe. I guess I forgot to show you one thing or two things. So let's fade back over here really quick. So one of the things you're going to have to do is you're going to have this meter that's hooked up to the shunt probe, and you're going to carefully adjust the voltage on the power supply so that it reads at 0.8. Now you got to remember how much drift voltage you have, and it's going to be changing a little bit. It should be stabilized in lab, but it might still change a little bit. And so keep track of how many digits it fluctuates. Now this other meter, you're going to have to come in and zero this Hall probe a little bit with this gray box. And so you just turn the knob on the gray box and go back to 0. And through another 5 or 6 measurements, come back and measure again. Notice inside it's really strong. But then you'd come back and put it in, and you would once again keep track of that drift voltage, and then you would also zero it again. I had a drift voltage about 0.03 here, and over here I had a little bit more drift voltage. And we'll look at that in just a minute. So let's go ahead and fade back over to my screen. And I'm going to skip over just a couple steps, and yeah, I do that sometimes. I apologize. And I'm going to do error in the voltage Hall probe. And so this is going to be in volts. And I wanted to skip over this just so that you can see how to do these uncertainty formulas. And so, for example, like the pre-lab. So I'm going to say is going to be column B, but some of them are negative and some of them are positive. And so I'm going to really do ABS of column B. And then I'm going to multiply it by, times it by 0.005 for 5%. And then I'm going to add in the 0.001 for the last digit. But then I also saw a drift voltage of 0.003. And if you look down the column, all the uncertainties are a little bit different from each other. But that's okay. So now let's get back to measuring the current. And so for the right-hand side, we got to have a couple things. And this is going to be in Tesla meters. And we got mu naught. So let's just do it this way, mu naught. And we also got the current, and we also got the number of turns. And so mu naught is 4 times pi times 10e neg 7. And I believe when I do the E, it'll automatically do it, and then times it by 1750, and then also times it by our current, which is going to be 1.2. However, on the right-hand side, when we're going around the entire loop, the net currents is actually going to be 0. You got to describe why that is, but you have to tell us why the net current is 0. And so when I add in a column on the right-hand side for the error of the right-hand side, the uncertainty is also going to be 0 for now. And then when we do around the one part of the coil, then it's not going to be 0. Okay, now to do the sum of the steps, we got to take the magnetic component. Actually, it just says we got to sum up the voltages and then multiply it by the proportionality constant and then the step size. But we can also, it might be more helpful to add up each one individually so we can calculate what the uncertainty is at each location. So let's go ahead and do that. We're going to go ahead and do the left-hand side of Ampere's law. And so we're going to take our column B and we're going to multiply it by our proportionality constant, 0.0111, and that converts the Hall probe voltage back into a Teslas. And then we're going to also multiply that by 0.02. And that's our step size, our 2-centimeter step size. And we get lots of numbers. Now to find the sum of this, we just select the top cell and we scroll down to 38. That's for me. And scroll down to whatever number for you. And we just do statistics on column right there. And so I'm just going to go ahead and hit quantities. We don't worry about the mean or the standard deviation or the total. We only worry really about the sum. I have to click off to this one again to hit OK because my screen's not big enough. So let's go ahead and look at that. Now I get a sum of 4.2 e to the negative 5. I'm going to write that down really quick. 4.24 e to the negative 5. Now when doing uncertainty, we're going to add a whole lot of things together. And so to do uncertainty, what we're going to do is we're going to find the uncertainty at each step, and then we're going to square them and then take the square of the sum. So that's not too hard, is it? Especially when we're at a spreadsheet. So this is going to be the error of the left-hand side. And this is going to be equal to f times it by the square root. Now, here's where I like to do a little parentheses trick. There's 3 things with uncertainty. So I'm going to do parentheses squared plus parentheses squared plus parentheses squared, and then close off the parentheses. Oops, I forgot to do a couple of the carets. Shift 6. Okay, now the first one, I'm going to take the C divided by B for the uncertainty of the voltage. So I'm just going to do C divided by B. So that's the ratio. Now the next one, let's do the Hall probe. So that's going to be 0.0002 divided by 0.0111. And then finally, the uncertainty of the step size. Well, guess what? It's kind of hard to measure, and are you really holding it square and all that kind of stuff? So the uncertainty in the step size should be a little bit bigger. So I'm going to say 0.2 divided by 2. And that's centimeters, and the units cancel, and great. So now I get a whole bunch of these numbers. Now I got to take the sum of these numbers and then take the square root of them. So I'm just going to highlight cell number 1 again and scroll all the way down to 38. I'm going to hold down the shift. Now I'm going to do statistics on column again and go ahead and hit OK and hit yes. Now there's my sum right there. It's 3e to the negative 6. And I come to the next page and I'm just going to type it in right here, equals to square root of the sum, which is in column E. And so there I go. So my sum was actually 4.42 e to the negative 5, and the square, my uncertainty is 0.0186. So I'm definitely within a z-score, 0.0186 for my uncertainty. Now, it's actually really quick and easy. We already done almost all the formulas for the going around the loop as well. We just got to change just a couple things. So let's go back to sheet 1. And remember I said we're going to change this uncertainty formula right here on this right-hand side. So now we're going to change this current back to 1.2. And the right-hand side should be 0.026 roughly. And the error of that right-hand side, now we have to worry about the uncertainty of the meter and the uncertainty of the resistor. And mu naught doesn't have an uncertainty, but the turns did have an uncertainty. Now, so I'm going to say is equal to column D times the square root. And I'm going to do a parentheses trick again, squared plus the parentheses squared plus a parentheses squared. Now, now this is slightly deviated from the lab procedure. I'm sorry when I do that, but sometimes I do because I try to teach you a little bit to think for yourself. And so what I'm doing here is if you were to take the Ohm's law like you did for the pre-lab and calculate the current, here I'm just separating those uncertainties back out so that you can kind of see that, oh, those two uncertainties, if I took the square root of the sum of those squared, they would be one value up and bottom squared. But now I kind of unfolded the equation a little bit. Crazy. All right, so first, the uncertainty of the voltage. So the uncertainty of this thing is going to be, I have to use a couple extra parentheses here, is 0.5% of the voltage, and the voltage was 0.8 to get 1.2 amps. And so my extra parentheses on top, I'm going to have 0.5% of that. So that's going to be 0.004 plus that one in the last digit, so plus 0.001. Plus, I saw a pretty big drift voltage on this because my system was still warming up. So I'm going to say 0.02 for my voltage. And I have to divide all that by 0.8. So that's the first uncertainty. Now the second one is going to be the number of turns. And that's really easy. It's just 1750. No, it's 5 divided by 1750. We had students doing this, and they kind of lost count once in a while. So we had to weigh them, and we just estimated based on weight that they were within 5 turns, plus or minus 5. And then the last thing we got to do is the precision resistor, and that's it says it's a 1% resistor, a 0.667, so it's a shunt resistor, can handle a lot of current. And so I can type in 0.00667 divided by 667, or guess what? It's a 1%, and this is a ratio, and so I can just type in 0.01 right here. And there, boom, done. All right, I've missed a parenthesis somewhere, so I'm going to have to open up the dialog and see if I can find it really quick. There's 1 right there, and there's 2 right there, yep. And there's 3 right there. I got to add in one more parenthesis up here, I think. And then go all the way to the end. And let's see, apply. Did that work? Yep, great. So that's my uncertainty for my right side now when I'm doing a mu of this. And if you notice, this is 8 to the negative 4. And so if I count this, 0.0263. So the 8 would go right there. It actually rounds up to 9. Okay, so now we're doing from 20 to 38. So I'm going to come back over here to my formula of the left-hand side and highlight row 20, scroll all the way to the bottom, highlight that, and now I'm going to do statistics on column on this chunk. And I'm just going to go ahead and hit OK. And yes, and remember, we're summing up those components. And now I got a sum of 0.00289. Which seems a little bit different when what I just calculated, so I might have made a mistake. 0.0289. So it's 1750. It's this number. It's to the 6. Nope, that wasn't right. It's to the 7. All right. I expect another 0 in this because it's actually 1 e to the 7 when you type it in that way. 0.0264. That's correct. Okay. Now that compares to my 0.0289, but we got to also do our uncertainty. Because remember, it's this 4 out here where the 8 goes to. Okay, so now let's go ahead to our error in our left-hand side. I'm going to highlight 45 and then hold down the shift and go to 20. And then I'm going to do statistics on column again. And go ahead and hit OK. And hit yes. And I'm going to go ahead and to the next tab really quick. And remember, we're doing the sum right here, and we got to do the square root of the sum. So I'm going to add in a column, and that's in column E. And so I'm going to do square root of E. And I get 0.017. So I made a mistake somewhere. 0.017. And I'll have to take a look at it and be right back in a little bit. All right, I'm back, and I found out where I made my mistake. My mistake was that I forgot to square the error in the left-hand side. Because remember, when we add and subtract things, we square the uncertainties and then add them up, and then take the square root of the whole thing. And when I do that for the uncertainty of the left-hand side for the first set, I get sum of 1e to the 9, but then when I take the square root of that, I get 3.6e to the 5. And so if I go back over and do my calculations, did I do them right here or did I do them right there? Oh, I didn't actually do them right there because of the uncertainty was just a little bit smaller than the measured values from 0. I got a z-score about 1.2. I should have typed that in right there. But I didn't. Oops. All right, so then when we did the second set, likewise, you came down to the number that you started for the second one and then all the way to the end. And I did column statistics. And then on that set, I got an average or a sum. Oops, that's number 2, this one right here. I got a sum of 0.0289. And that compares to the value that I measured for my current right here. Error right-hand side, 264. And my uncertainty is 9 to the negative 5, and so that's this digit right here, this 4 in this last digit. Now I go back to the end, and I also did the uncertainty of the last column, that error in the left-hand side squared, and I got a value, a sum of 6e to the 9. And then when I come over here, I take a square root of that, and I get 8e to the 5. And so when I do my when I do my z-score, I do the absolute value of those two numbers and divide by the square root of my first uncertainty squared, my second uncertainty squared. I get a z-score of about 1.6. So I got about 1.2, 1.6. That's a really cool lab. I mean, you measure magnetic fields and such. Now for the post lab, what you're going to do is you're going to be taking a picture of this equipment. And so get your cell phone out, take a picture, and then draw some lines to the different pieces of equipment and state what they are. Or maybe say A, B, C, D, E, and talk about what the equipment was doing. Talk about the measurements you made, like the Hall probe. You walked the Hall probe around and took the measurements, and you multiplied the magnetic field measurement by a step size. And then also state your results for both going around the outside and then going through the middle loop. And that's about it for today. Thanks for watching.